Okay, so next up, we have Angelo Ruocco from IBM. He's a researcher and software developer at IBM Research. He has previously worked with partition hypervisors, and currently he's interested in the security and attestation of VMs, which is one of the hot topics of our meeting today. So please welcome.
Okay, so my name is Angelo. I work with IBM, and I'm presenting our work with the development of an ephemeral virtual TPM to allow remote runtime attestation for confidential virtual machines. There's a lot of words. I'll try to go one by one and to explain what those are and why do we need this. So first of all, TPM device. I guess you're familiar with it, if anything, because now it's mandatory for Windows to run. And so what it does, it measures the binaries that are run on the machines. Everything you write is immutable until reboot. Only thing you can do is extend what you're writing to it. And everything is signed with a key, and it acts as the root of trust for your attestation. So you can go back into your chain of trust, and this is what you trust. So it's used for remote runtime attestation. Attestation meaning that you want to attest that something is safe, it's secure, and it's the remote part means it's composed of two parts. You have the a local attestation service, an agent that asks the TPM for quotes, and a remote attestation, which is the one software that you do need to trust and that verifies that everything is expected. And it can actually perform actions based on the result of the verification. It can, I don't know, release keys or stop the machine if something is wrong. One important thing is that the runtime part. So we don't just want to measure the system at boot time. We want to continuously monitor it. And we do this using the kernel IMA-log, and we link the IMA-log to a register of the TPM device, so that every time you open or you execute something, it will be written in the IMA-log, and the TPM registers will be modified, and so that you can check every time you want that the system is okay, you can trust it. Now let's move to confidential virtual machines. It's basically virtual machines, but where the trust boundaries are redefined. You don't trust the cloud service provider anymore. You only trust the hardware, the CPU. And you do that via the attestation report that the CPU provides. One quick note about the ephemeral part, meaning that it's stateless, so that the code base is, this has the advantage that the code base is smaller, and you have less headaches for injecting the state, the keys and stuff like that, but you have less features. For example, with a TPM, you can store keys in it and they can be released automatically. If the measurements are good, you cannot do this with a ephemeral TPM. Finally, this is a virtual TPM, so it's software. It's not a physical device. It's something that's emulated. And this is a challenge because, so this is the trust model of remote attestation. You don't trust your software. You don't trust your agent. You only trust the TPM device, which is your root of trust. And you trust the remote attestation service. And you don't have a TPM device. This is the confidential VMs trust model, where you do not trust the host. You trust your service, your software, and you trust the attestation report that the host provides you. And when you combine the trust models, you have the intersection, which is this. Basically, you trust nothing. And this poses an issue because the TPM is virtualized. It needs to be run somewhere. And if you cannot run it in the guest because it breaks the attestation trust model, and you cannot run it in the host because it breaks the confidential VM trust model, where do you run it? This is where things get a bit messy because each platform is doing confidential computing in a different ways, as we have seen in the previous talks. And giving an example here, and it's AMD vision of confidential computing. And AMD has VMPLs, which are virtual machine privilege levels. Basically, each enclave can be partitioned in the different levels, and you have lower levels that have higher priority and that have control over the access by lower priority levels. So what we can do is take the BTPM code and run it in a higher priority VMPL. And this is how it looks. We have the host, we don't trust. The guest is just to show it's there. And we have the VMPL 0, the highest level that we can trust. We put the BTPM there, and we have our software, the one that we want to monitor, that we don't trust in a lower VMPL level. Now, great. We have our TPM, we put our software, we can just start getting calls to it, and the agent can talk to the remote attestation service. But one big issue is that how can we really trust the BTPM? So what we do trust is the attestation report. So to link the trust from the BTPM from the attestation report to the BTPM, we can simply make the BTPM retrieve the attestation report for us, and then it will just pass it to the attestation service. So the attestation report that we have is going to say that this is a higher level attestation report, higher priority level. This is a BMPL 0 attestation report, so that we do know that it's a true attestation report. And also we have inside the attestation report, we have the digest of what's being quoted. So we have the it includes the hash of the BTPM itself and our operating system, our system stack. Now, another thing is that TPM uses its internal key, which in a physical TPM never leaves the TPM, it's baked into it. But our BTPM is stateless, so the key is it's ephemeral, it's stateless, it's created every time you put the BTPM. So what we get from the quotes that we get are signed with some keys that we have no way of checking. And what we can do is use we can use the user data, as Samuel said before, as a nonce. We just put the public key. We ask the attestation report to include the public key of the BTPM, so that we can retrieve the public key normally in an untrusted manner, and we can compare it to what's inside the attestation report that we do trust. So once we have the attestation report with the public key that now we trust, we also trust the private key, and we can start trusting all the quotes that we get from the attestation report. This is the final picture of how things are working. We have the host we don't trust, we have our software that we don't trust and that we want to attest. And we have our BTPM, which includes the attestation reports with the pub key of the BTPM itself, and the attestation reports that attestation agent that what it replaces and talks to the attestation service for runtime attestation. A few more things that I want to mention is we developed this using the Linux SVSM, which is a proof of concept by AMD to use BMPLs. But now things are shifting to Coconut, which is an effort by the open source community to unify things so that you are not tied to AMD, for example, with its BMPLs. You can use, for example, Intel has a version which uses a sidecar enclave to put the TPM, and they are doing something similar with ARM CCA and stuff like this. And yeah, another thing is that open source is kind of a requirement here. I think Samuel already touched on this because you need to be able to measure things yourself. If you want to shift trust away from the CSP and it's the CSP that gives you the measurement, then it's kind of a conflict of interest. And yeah, this is it. I try to be quick so that you can get some time. If no one has questions.
I mean, it's just a short question. So in comparison to like a traditional TPM, which is like, I don't know if there are many anymore that are like connected, like a dedicated chip connected via bus on the CPU or something, or if they're already in the CPU, I don't know, but in classic context, they're like from the privilege level, like more or less equal, or the TPM is like less privileged than the normal OS context, no? Because the TPM, it can't interfere with your operating system. And
yeah,
you can send it something, it has it, you have some key material you can use. But in this case, because it is more privileged than the rich application, it potentially could interfere with the application.
That's correct. But in theory, you have your source code, you can see that it does not do that.
Okay, but if you can communicate from the remote, you can communicate remotely with it, then there's a chance that it can
you cannot communicate remotely with it.
Ah, okay. So it's over the
yeah.
Okay. Okay.
Like this is an issue when you want to do a stateful BTPM. If you want to keep keys in it, then you need to create a channel and you need to communicate with it, and that can cause issues. They are working on it. I don't know if it's secure enough. That's for academia people to do, but it also adds a very larger code base to this, and larger code base is usually more prone to bugs.
Any other questions? Able to do work to migrate the workload because it's
yeah, you cannot. Once you turn it off and you put it to a new BTPM, it's removed from the attestation service. And
at some point you were mentioning like the hash of the public key is like as announced.
yeah,
That was not very clear to me. You mean using the announce field to put in your public key? Is that what
so you have your attestation report that you retrieve from the VTPM, and the VTPM it's the one asking for the attestation report, and as user data as announced, it puts its own public key so that you get the attestation report from the VTPM and you have everything. And
my question just to verify is what it has got to do. That I completely understand. So you generate a key there, you put the public part inside the attestation report, that's completely fine.
Yeah.
But what I am struggling to understand is what it has got to do with the noise.
That's the usual trick we do to build
like the different evidence, like that's done in various different, like we do it also with the key attestation with the ESA attestation plus. We also link the platform evidence to the key attestation using the nonce, because we have these two independent blocks. The platform attestation uses an API that just allows you to says, give me the evidence, here's the nonce, but then you get the evidence back. But now, since we want to extend the API, but then we have another payload, the key attestation payload, we need to basically pass in the hash of the public key instead of the nonce value, and then the two structures link together. I think that's what you need to say.
Exactly. Yeah.
It's a good figure. The figure is I was confusing to some extent because I think when you say the attestation report is that so where's the platform attestation from the CPU in here? Is that the attestation report which has the hash of the public key in there, or so like because you assume a confidential computing environment?
Yeah.
In this case, so you also have another layer of attestation here besides the one from the TPM.
Yeah.
Which is from the hardware. Where's that one shown in the figure?
It's the attestation report. It's you get it from the BTPM. The BTPM talks to the CPU.
Oh, so you can store that.
And you put it inside the BTPM. And
so that's what the agent in the software is, that maybe the channel to the BTPM, or is it also the channel down to the lower part? Because I'm missing the error here from the BTPM down to the CPU.
yeah, it's missing, but
it's there.
Yeah, it's there. Okay. That's code inside the BTPM. I will update the slides with a link to our proof of concept, which if you have a AMD SMP machine, you can run it. We also have the patch ready for we use Keyline to prove this. It's an attestation service, and you can have everything. Your VM with the BTPM and Keyline that recognizes the BTPM and can do normal application stuff.
Question. So in this example, we'll go back to this. The BTPM that you have here is also performing some of the functionality that UEFI might do in a typical PC by actually making the measurements from the host. So where does the PCR values come from?
Well, yeah, it starts from the UEFI. The thing that initializes the TPM is the UEFI, the guest UEFI that initializes the TPM, that's the BIOS, and then.
Yeah, no, UEFI works, but in this example, where does the TPM get? Is it getting PCR values from it's also reading them from the host, or is it purely within the guest?
No, it's purely within the guest.
So where is, for example, its PCR 0?
From the BIOS of the guest BIOS.